In this video, I will discuss Principal Component Analysis or PCA. I will also implement PCA in Python. We will see how it can be used for data analytics and data science problem in general. Principal Component Analysis or PCA is a fast and flexible unsupervised machine learning method. Unsupervised means it can be used to analyze unlabeled data or the data about which we don't know which sample belongs to which category. This technique is widely used for dimensionality reduction. It's most suitable for visualizing multidimensional data by looking at it in two-dimensional space. Let us think of a two-dimensional data set. Using this data with two features or column, we want to represent this two-column data with a single column. We will need to transform this new column such that it better represent two-dimensional data. This new column can be thought of as a line that is a linear combination of these two-dimensional data and explains maximum variation, as illustrated by animation here. The first step is data normalization. It prevents one variable dominating others in case if each value have different dynamic range of values. In this step, each variable is subtracted by its mean and divided by its standard deviation and results in variables with mean 0 and standard deviation of 1. Then we calculate covariance matrix, which is a symmetric matrix, and each element I, j corresponds to the covariance between variables I and j. It represents the measure of the directional relationship between two variables. Then using this matrix, eigenvectors and eigenvalues are calculated to fit a line that account for maximum variation. These are eigenvalues. Such a line minimizes the perpendicular distance of each point from the line. Direction of this line of length 1 is called a unit vector or eigenvector. This unit vector eventually becomes the weights of the principal components, also known as loadings or rotation. The eigenvector with the highest variance or eigenvalue corresponds to the first principal component or PC1. The second principal component is the eigenvector with the second highest variance, and so on. The final step is data transformation in new dimensional space. This is done by multiplying the original data by computed eigenvectors. Now we illustrate PCA in Python. We start by importing packages and loading data. We will also normalize data. Then after calculating covariance matrix, we will calculate a values and eigenvectors. Let's now see how much of variance is explained by each principal components. To understand how much information each principal component captures, as we can see here, PC1 is able to capture more than 35% variance. Now we can select top two PCs and transform the data in new space for visualization. That brings us to the end. Thanks for watching.